Hi, welcome back to my statistics class. So today we'll give you more example about a sampling distribution of means. So starting with a population that is not normally distributed. So if it's not normally distributed, that means when we're trying to apply the central limit theorem, we need to consider the sample size. Okay. So now let's take a look. How do we consider about that? A restaurant bill is given a restaurant bill at a given restaurant have an assumed population mean of $13.40 and the population standard deviation is $8.16. This data is heavily skewed to the left. So what does this look like? The tail is the skew, so it's left skew. That means the tail is on the left. So it's more like this one. So the mean maybe is here 13.4 with a deviation of 8.16. Okay, even though you look at this deviation doesn't mean this is a normal because they told you that hey, this data is heavily skewed to the left. So explain why you can determine that the given bill will be at least 35. Because we don't know the population distribution. So we cannot know how do we determine a bill will be less than 13.5, even though they've given you the mean and standard deviation. Because we don't know the probability distribution. So we can't determine that the given bill will be at least $13.5. Okay, can you estimate the probability that the next 5 bill will be average at least 13.5 and discuss each of the conditions for using the sample distribution of mean? Okay, so in order, because we know that with sampling distribution, if the sample size is large enough, it's going to follow a normal distribution. So now by the central limit theorem, first of all, it has 3 conditions. Is this independent? Yes, because the first bill is not going to affect the second bill or the third bill, so each bill they're independent. 2, randomization. Is this a randomized bill that we picked? Yes. And the third part is the sample size. The sample size has to be big enough. So they're telling you that, hey, we just picked the next 5 bills, which is the sample size equals to 5. So this is not a big enough sample size. So that means we can't apply central limit theorem because the sample size is not big enough. So that means we cannot estimate the probability that the next 5 bill will be average at least $13.5. C, if we take the average of the next 50 bills, would it all be condition will be met? Yes, because it already met the first 2 conditions, independence and randomization. Now the sample size become 50. We will say, hey, this is a big enough sample size. So the condition missed. So that means we can apply it since the sample size n equals to 50. So we can apply central limit theorem. So let S bar be the mean cost of the next 50 bill. Okay, so remember the property of a sample distribution. Mu S bar equals to our population mu, and then the sigma X bar equals to the parent population divided by the square root of sample size. Okay, so we know that mu x bar equals to mu, which is 13.2.14, and then the sigma x bar equals to 8.16 divided by square root of 50. So now let's use a calculator. So we have what? 8.16 divided by square root of 50 equals $1.15. Okay, so we know that this is what? This is follow a normal distribution. X bar follow a normal distribution with the mean $13.40 and the sigma equals to $1.15. And we can even draw, oops, I think we already answered the question from D. Define the model with its parameter and draw the neighbor. So here, we already defined the model, which is a normal distribution model, and now we still need to draw it. So we have the mean with 13.2.4, and the one standard deviation is what? $13.40 at $1.15. We have 13.350. The two standard deviation would be 13.471, and then 3 standard deviation would be 13.5.86. Now let's take a look at the other side. We subtract 1 standard deviation, we have $1.25. The second, subtract 2 standard deviation, we have a 13.1, and subtract 3 standard deviation, we have 28.95. So this is going to be our normal distribution. This is not a really nice curve. It's supposed to be really symmetric, but I'm really bad at drawing. So remember, within 1 standard deviation, this should be what? 68% of the area. And within 2 standard deviation, this would be 95% of the area. Within 3 standard deviation, this would be 99% of standard deviation. I mean, it's 99% of the area. Okay, how likely is that the next 50 bills have the average of at least $13.5? Okay, now they ask you the next 50 bills. That gives you what? That means you're trying to figure that out from the sampling distribution, not the entire bill. Not the entire bill from the restaurant. That only tells you that, hey, the next 50 bills have an average of 30. So what we can do is we let S bar be the variable of the next 50 bills, the average of the next 50 bills, of the mean of the next 50 bills. So we know that X bar follow a normal distribution with a mean $13.40 and a sigma of $1.50. Now we use GeoGebra trying to figure out that when X bar is greater than or equal to, because this is at least 13.5. So now take a look. GeoGebra, we change the mu equals to 13.4, and then sigma equals to 1.15, and then X is greater than 13.5. So we have 0.119. 0.0119, which is 1.19%, 1.19%. Did I do it right? Yeah. Okay, so that's it for today. Let me know if you have any other questions.